This is assignment 2, case 4, a plate tilted at 90 degrees. Here is my student ID. PID is 4065587. So to begin again, just like the other videos, we're going to start with our XY plane and how we got this little plate tilted upwards. So let's start with our sketch. So I'm going to go to sketching. Let me zoom in really quickly on this. All right, so for this, I didn't really have to do any angle positions. All I had to do was just create a rectangle, draw it like so, and then go to dimensions, click general, and then drag off a little piece of each wall. And then in the, let's see, detailed view, yeah, here, you are able to input the lengths, the exact lengths you'd want those positions to be in. So for this height here, I wanted 5 centimeters, and for here, I wanted 50 centimeters. After that, I needed to create a larger rectangle for the system. In order to do that, I went back to the sketching, draw rectangle, and I drew a rectangle across this entire area here, making sure to leave enough area in the back for the wake. After that, I went to concept, surfaces from sketches. I clicked this area here, and then clicked generate. And that gave me this gray surface you see in the background and left the plate open, so there would be external flow that goes around it. After that, I need to go to the meshing stage. For this, let me open the mesh. This is what the final mesh looks like. In order to do that, I go to mesh, I go to insert and method. That will insert an automatic method for the mesh, so it'll give you a general mesh. It won't be that great, but you can work with it. After that, you can go to the automatic, actually, yeah, you click back on mesh, and then you go to the element size, and you can actually lower it to 0.05. To refine that even more, you can go to mesh, insert, and refinement. From there, you can click on refinement and click the refinement level to 2 and generate, and that'll make it what it is right here. Next, we have to do our name selections. So we're going to name our system inlet, which is here, our system outlet to the right, our symmetry, the top and the bottom. And before, we have to name the parts of our plate so we can get our forces, the front of the plate, bottom, back, and top. And once that is done, we can move on to the last stage before we contour, which is our solution. As I said before, the solution is completed already. This is just me going back through showing you how I got to my solution to save on time. So in order to get to our solution, we get models, we go to viscous, we will open the K epsilon, we will do standard, we will do enhanced wall treatment, and pressure gradient effects. Once that is done, we'll be good to go. We can close our models, go to materials, fluid, air, like we used for the last ones. Next, we can do our boundary conditions, do our inlet, and make sure that our inlet is 10 meters per second. We also have to make sure our outlet is a pressure outlet. Next, we can go to our reference values. Make sure we are computing from the inlet, because that's where our flow is coming from, and your velocity will change as well. Next, we can go to initialization, hybrid initialization, and initialize our solution. We can then go to run calculation. Make sure we set our iterations to at least 500 just so we can get, or not even 500, just like a big number so we can get to a solution. And then we click calculate. Once the calculation is complete, we are able to access the reports and the forces. Let's print those out on the screen. Get rid of our task page. Like that. And our forces are actually going to be right here. So here's our pressure forces, our viscous forces, and our total forces for the back, bottom, front, and top of the plate. Following this, we can go to our workbench. I'm going to share that very quickly. And we can open our results. And the results is where we can do our contouring. So here is where our results page is. We're going to go to the XY plane. And let's do the velocity contour first. So we're going to go to contour. We're going to do velocity contour. Okay. Symmetry 2. Velocity. And 200 contours. Let's wait till this loads, so it'll take a second. And here we have our velocity contour. Let me get this so we can zoom in on it. As you can see, we have a much larger wake region now that we have the maximum surface area that the flow is hitting. And we also have quite a large stagnation point here as well. And we can actually see that stagnation point when we insert our pressure contour. So actually, I'm going to take off, pressure. Okay, I'm going to take off the velocity contour. Location symmetry 2, pressure is already clicked. All right, 200. Apply. And as we can see here, we have a very large low pressure region in the back by the wake, and we have a very large area of stagnation here, large area. So there's going to be almost no velocity at the front of this plate, which makes sense because it's a flat plate now. So once that is complete, we can actually see where flow begins to separate, and we can do that by going to the vector right here. I'm going to call this, we'll call it flow separation. Okay. Take off the pressure contour. At locations, we will do symmetry 2, velocity, and apply. So as opposed to the other cases, you can see here the flow separates much, much faster. So, you know, that's why, again, there's a large wake, and that's why there's essentially more pressure drag going on, because there's a fast flow separation. To see exactly where this flow separates, you can go back to your setup, go to the XY plane with the plots, and you can plot your shear stress along your top plate and see wherever the shear stress is 0, because that means there would be there'd be no flow. So you'd have that flow separation. That will conclude assignment 2, case 4 for the horizontal or 90-degree plate. Thank you.